Hi everybody, welcome to this edition of MOCPA Bar Talk. I'm Andrew Groh, and today we're here with Dr. John Seiffertt, Assistant Professor at Providence College in Rhode Island. Dr. Seiffertt, welcome to the show.
Thanks, Andrew.
Thanks for coming on today. I understand that you're a Missouri native, is that right?
That's right.
Okay, can you tell us a little bit about yourself?
Yeah, I grew up in St. Louis. I've now moved out to New England. Can't quite bring myself to root for the Red Sox and Patriots yet, but we're out there now in Providence, Rhode Island. I taught at several Missouri institutions. I taught at University of Missouri St. Louis. I did my graduate work at Missouri University of Science and Technology, where I got interested in artificial intelligence, and I have also taught at Truman State up in Kirksville.
Well, welcome home. This is fantastic, and we have also known each other for a couple of years now. You've come in and been one of our experts in blockchain technologies for the Midwest Blockchain Conference. So thank you very much for all of your expertise on that front. And today we're going to take a deep dive into your primary expertise, artificial intelligence. Can you tell us a little bit about the technology itself? Kind of situate us. If we're not familiar, CPAs are not familiar with AI, where is AI in kind of the technology spectrum?
Yeah, Andrew, that's a really important thing to do because there's a lot of different kinds of technologies out there, and people who aren't creating the technology for a living are oftentimes faced with just so many choices of where do I go? What is the difference between all of these? So if you take what I would call a normal piece of software, something like RPA or something like Microsoft Excel, it is based on basically a sequence of what we call if-then statements. Anyone who's taken a programming class has written a statement that says, if the input to the system is this, then I'm going to do that. It's pretty straightforward. It might not be easy to develop that software. Software is very difficult. A lot of human intelligence can go into the development of the software, but the software itself is not something that we call intelligent. We don't call that software artificial intelligence. What distinguishes a normal piece of software from intelligent software is that the intelligent software is going to fill in gaps where the programmer did not specifically specify what to do. So in Excel, there's programming behind the scene. Say, if I click in this cell, something will happen. Right. So it's just a bunch of if-thens. In artificial intelligence, it's used in applications where it's impossible to do that. So take chess playing, for example. If you take Magnus Carlsen and have him come into your company, and you could ask him, you could show him 1,000 chess points, and he could say, well, here is the correct move in all of these 1,000 cases. You would have the beginning of a normal program that could play chess, because presumably he will make the correct move in those cases. However, there are too many chess positions for a human being, even Magnus, to actually write down. You can't enumerate all of them in a human lifetime. So an artificial intelligence algorithm will come in and it'll say, okay, well, I've got some chessboards where I know the right answer for. I'm going to perform some sort of interpolation, some sort of trend line. If anyone has statistics background, there's an approach called linear regression, where you try to figure out what lies in between the data points that you do know. So that's what AI will do. It will fill in those gaps, and in effect, it will write its own program. So the cool thing about AI is that it is a piece of software that writes a piece of software.
Right, and talk a little bit about that and where we are kind of in the technology. You mentioned RPA, robotic process automation. Yes. Is robotic process automation kind of the base or the first set of what AI then continues to do? It's a piece of software that's been coded and to do one specific task, and then AI ostensibly or basically can then continue to rewrite.
Basically, RPA is used for situations such as transferring one type of file to another type of file. Those are situations where the engineer will get down and look at the details of the different file encodings and simply write the if-then statements that perform the transformation. And again, I don't want to say that that's an easy task or that kind of development isn't.
Could I do that now?
Probably not. Human intelligence, but it's not what we mean by artificial intelligence. because you are pretty sure that that task will succeed. It will successfully transfer from one file type to another 100% of the time. Now, software might have bugs, just like when you frame your house, the builder might have something a little bit wrong, maybe your windows a little bit askew, but controlling for bugs, so the normal software, something like RPA, you can be confident that it will work all of the time. One of the things about AI is when you have a program that writes another program, it's that second program that's actually doing all the work. And it's that second program that we don't really have access to. We don't really know what that program is. It's very hard to audit. It's very hard to understand. So all of those points that Magnus Carlsen didn't specify, we can hope that they are correct, but we don't know. And it's impossible because there's too many states to actually go back and check all of them and make sure it works.
Right, and that second piece of software, you mentioned linear regression, and I can't remember the other piece of that software, but tell us a little bit about that. Why then, as maybe you go from, in AI, you go from that base piece of software to the second layer, the third, or the 100th layer of rewritten code, why do things kind of maybe tend to break down?
It becomes more obscure because that second piece of software is basically a list of billions of numbers. And in linear regression, you have a very simple mathematical formula to relate the input to the output. In a sophisticated artificial intelligence algorithm, that equation is going to be very, very complicated. And you have billions of parameters, and it's just not possible to go in and translate that big set of numbers into something that a human could check for error.
So if I'm not familiar with linear regression or big data sets and how software can adapt,
mm-hmm.
What's a good example? If give me an example of how this may operate if in very basic terms, how something could break down.
It can break down when that second piece of software that's written doesn't interpolate properly. So you could be playing a game of chess, and when you're close to one of the moves that Magnus made, you're golden. But if your opponent gets you into a situation that isn't close to one of the boards that you know for sure the answer to, you might be told to do some crazy things. Queen sacrifice for no reason or something, because the algorithm just might not have done it. When we talk about an artificial intelligence algorithm, we talk about the first algorithm. It's actually a meta-algorithm. It's an algorithm that creates another algorithm. So those of us designing artificial intelligence algorithms, we are concerned with the creation of another piece of software, basically. And it's that second piece of software that actually does the work.
So in your field, though, how can you interpolate? How can you say this piece of software that I'm going to build, and it's going to build on itself, is going to actually get to where we think it's going to go? How do you even work or think about those types of things?
Well, Andrew, that's an excellent question to weave through an entire PhD in artificial intelligence. That is the heart of it. How do you do it? Like, how do you actually get a computer to adapt? How do you get a computer to learn something? It's a fantastic question. One of the ways that I look at how to do it is you receive some sort of feedback from the environment. So in a game-playing computer program, if you make a move that leads to victory, that move will be rewarded. And so you have a score sheet, basically, and you say, okay, well, this move gets more pluses on the score. There's a lot of different approaches to it. And as a non-technical person, as someone not creating the technology, as someone looking to use the technology, it can be mind-boggling. This is where terms like deep learning are thrown around. Deep learning is one of the techniques used to answer the question that you said. It's not a separate thing from artificial intelligence. It is a particular method within artificial intelligence that's used to create algorithms to solve certain kinds of problems. It's become very, very powerful in the last 5 years, primarily due to advances in hardware, not in software.
So talk about that a little bit. Are we talking about the ability to crunch big data in larger and larger scope and size? Are we talking about supercomputers? What about hardware?
That's basically the gist of it. As computers get more powerful and as computers get smaller, right, we have the equivalent of 1980s era supercomputers in our pockets these days. The new iPhone has a neural networks chip on it that is specifically designed for doing artificial intelligence calculations. And we've got this tremendous amount of power there. And we waste it by using it to tag photos on Facebook. That's what you use it for. You put it in there and you tag the thing, and then there you go. You can more quickly associate faces in the picture with your friends. That's what we're using this advanced technology for.
I think that's awesome. And let's pause for a second because it's a great overview of your profession and AI. Thanks for watching. If you enjoyed this segment, check out the entire episode, and if there's a topic you would like to see us cover, comment below.